Hello, everyone. Nadeem here with PC.Solutions.Net. A question I get sometimes is, and this happened recently, so I thought I'd make a video about it. Network switches. How do you know if you're getting a good network switch? So here's the thing, and I'm going to try to keep it as simple as possible. We're not going to talk about tech. So you can get a network switch. Now we're talking about intelligent network switches. They're called managed network switches. So they have some intelligence built in where you can log into the switch and change some things around, make some changes to the configuration. We're not talking about dumb switches where you cannot connect to them, you cannot make any changes. It is what it is. So when it comes to managed switches, there are switches that will range from like a 24 port down from 900, and we're talking PoE switches, so around 900 some odd dollars, all the way up to like $25 or even $3,000. What's the difference? So you have to be very careful about which switch you select. For example, you want to make sure that the switch is not going to block packets. Now, when a bunch of different packets arrive at the switch, is the switch going to be able to keep up with all those packets arriving and process them in real time, or is it going to not keep up with that number of packets and the packets are going to get queued up? So the lower end switches, they will queue the packets, they will buffer it. And what happens is basically users will see that as a slowdown on the network. Now, in normal day-to-day operations, you're probably not going to see the slowdown. But if you have a lot of users on your network and these users are copying files, transferring files over the network, they are going to notice the difference. And they're only going to notice the difference if they time their transfer. So, for example, if one user is transferring a file, it may take 20 seconds. But then if 10 people are transferring files, instead of that, whatever 10 or 20 seconds it was going to take, it was taking originally, now it might take 40 seconds. So now we're talking about seconds, right? So 20 seconds, 40 seconds, a lot of times people are not timing these transfers. So it's like, they don't really see that it's that slow. But if you time it, going from 20 seconds to 40 seconds, that's, a lot of difference there. And that's what makes a good switch better, is when it has what they call non-blocking technology. So as packets arrive, it processes them and directs them to the proper destination. The other thing is there are things that you can control without getting into the technical stuff. The overall, there's a limit of bandwidth in that overall switch. A good high quality switch will have more bandwidth compared to a low quality switch. Think of it like your internet provider, right? So you can get a faster connection or a slower connection. Same thing with switch. You can get a higher bandwidth backplane, which is going to basically give you more throughput, or you can get a lower bandwidth backplane, which is not going to give you as much capacity, as much switching capacity. So these are some of the things that you want to look into, and if you are upgrading your network infrastructure, your IT admins will be able to better help you understand the differences between switches. Now, also keep in mind, avoid some of the very well-known companies as well. It's not always that the more a switch costs, the better it is. It's not always the case. Think of it, and I'll give you an example. I'll share some names. So, compare, for example, HPE Aruba with Cisco switch, right? Everybody's heard of Cisco, right? Now, the Cisco switches, I have yet to find a Cisco switch that comes with a lifetime warranty. Almost all HPE Aruba switches come with a lifetime warranty. When you compare the backplane, they're about the same switching speeds. Yet, the Cisco switch costs a lot more the initial buyout and then the SmartNet support that they give versus HPE Aruba where it costs less. And that's why Cisco is, they made such a lot of money, is because they are overly priced, because they know, hey, everybody knows Cisco, so we can charge what we want. On the other hand, HPE Aruba, I have yet to see a single port die on an HPE Aruba switch. In all my experience, I haven't seen it. There was one case where we thought the switch was bad because the local IT admin had made some changes, and it was, one port wasn't working. And then HPE has something called advanced replacement warranty. So they sent the customer a new switch, and the customer sent the old switch back. They put it in the lab, they tested it, found out it was just a config setting that was incorrect on that port. So I have yet to see a bad port on an HPE Aruba switch. On the other hand, I have seen several Cisco switches with bad ports on them. I think in all my experience, I've seen maybe 5 or 6 Cisco switches with bad ports on them. And sometimes you go to a new customer or a prospect, and you go in there, some of the ports are taped over, and you ask them, hey, why are these ports taped over? What's going on? Oh, those are bad ports. They burnt out, so we just put tape on it so nobody accidentally uses it. It's like, come on, guys. But so the thing is, it's not just about the speed. It's about the quality of the circuit, the quality of the ASIC in the switch that makes the difference. The quality of the solder that the switch has on there, the soldering, the process. Each little thing makes a difference. So that's why we internally kind of standardize on HPE Aruba switches, just because they come with a lifetime warranty. They have non-blocking architecture, and we can find switches in all categories. We can get them for powering regular networks. We can get them for powering iSCSI networks, and an iSCSI network is, think of it like your hard drive connected to your machine through a switch. And the reason why companies do that in their networks is so they have one central place for all their storage, which, a bunch of drives, which are connected via switch to all their compute nodes, their servers. So that's why you want to do that. Now, it's very critical in this case that the switch does not block any traffic ever, because the minute one packet gets blocked in a situation like that, your server is going to be screaming, hey, I can't write to the disk, or I can't read to the disk. Windows is going to start complaining, hey, there's a problem with your disk subsystem. So it is critical that the switch does not block packets, and that it supports large packet sizes, because it's really storage traffic that's flowing back and forth, not just regular network traffic. So that's in layman's terms, what makes a switch a good switch is overall bandwidth, non-blocking architecture, and then I think the best thing is lifetime warranty. I mean, if a company is providing a lifetime warranty and they've been doing that for over 20 years, they are confident in their quality control and their products. So that's it for today. Everybody have a great day, and be safe out there.